All right, this is section 7.6, and this is going to be the end of chapter 7. This is a long section, I'm not going to lie to you, okay? Because this one has things about buying a house and student loans in one section, and these could easily be two sections here. All right, so let's just dive right into it, okay? A mortgage. So a mortgage is just another name for a loan where you're buying a house, okay? But specifically, it's a loan where the lender has the right to seize the property if payments are not made. So the term is typically used for home buying, okay? So you wouldn't say that you're getting a mortgage to buy a car, okay? Because it's typically used for just buying a house. It's just a specific name for a house loan. All right, let's dive right in, okay? Example 1. This is going to be similar to homework problems 1, 2, 3, and 5. So when you go to do those problems, I want you to look back at this example for guidance, okay? A house sells for $160,000 and a 20% down payment is made. A mortgage was secured at 4.9% for 25 years. The terminology on these tends to be really overwhelming for some people, so I want to kind of explain this stuff, okay? This is the selling price of the house. 20% is your down payment. That means 20% of that price. When it says a mortgage was secured, it means you were given a loan to buy the house. So when you say you secure a mortgage, secured as in like it's yours. So a bank gave you a loan to buy the house. That's what a mortgage is. And here's the conditions. It was 4.9% interest that's going to be charged on this loan for 25 years. Okay, so houses typically are financed for very long term. You can get home loans for any amount. A lot of times they will be for longer terms, like 15, 20, 25, 30. Some are even like into the 35, 40 year mark. Okay, so part 1, and Alex says, find the down payment. All right, so the down payment, remember, is the percentage of this amount. So it's just 20% of $160,000. You got to make that into a decimal. So 20%. So over here, I come down here, little happy thought cloud. 20% as a decimal is 20 divided by 100, which is 0.20. Of meaning multiply, $160,000. Multiply those together and we'll get $32,000. That's the amount of your down payment. 20% is not a fixed number. You always want to know 20% of what. So it's 20% of this. Don't look at that and think it's $20 as a down payment. It's not. You actually have to do a computation with that number. Okay, so if you multiply those together, you get $32,000. There's your amount of your down payment. Part 2 says find the amount of the mortgage. That means find the amount of the loan. Now, all you have to do here is take the price minus the down payment. Okay, so we got that $160,000, and we're going to subtract that down payment of $32,000. That gives me a loan amount or a mortgage amount of $128,000. That's the amount you're going to be paying payments on. Okay, so what I try to do with these is not just do the computation. I do try to write the formula down to try to remind you. So when you're looking back at these, you have, some guidance to follow here. All right, part 3, same problem. We're going to use the TVM solver to find the monthly payment. All right, so here's my TVM solver categories. N is your total number of payments. Remember, this is the number of payments per year times the number of years. It's monthly payments for 25 years. So here, let me flip back here. So it was 25 years. Now, it doesn't say, I was actually going to look and see if it said anywhere about monthly payments. It doesn't, but you can assume that it is monthly payments here, right? If it doesn't say otherwise, assume it's monthly payments. All right, so we got monthly payments for 25 years. That's a total of 300 total payments. The interest rate was given to us. That's the 4.9% that was given. The loan amount is this PV. Now, this is the amount that we found back here in part 2. Okay. Now, look, when it comes to the percent, 4.9, don't accidentally put 20 in there. That's the percent for the down payment. We used that one already. This is the mortgage, okay? The mortgage says it was secured at this interest rate. So that's going to be your I value. Payment is what we're going to be solving for. And then again, like most of these, we're paying it off and it's monthly payments. So we're going to put all that stuff in the TVM solver. So it's under apps, TVM solver. N is 12 times 25. So you can just type that in, 12 times 25, and it'll do the computation for you. 4.9 interest. The loan amount here, that PV, is that $128,000. Now, as these numbers get bigger, I want you to be super duper careful because it's very easy to forget a zero with these because these numbers are going to be big because we're talking real world problems here. All right, the payment amount we're going to solve for, and then 0, 12, 12. So we go down here to the payment line. Make sure you're blinky blinky on the payment line if that's what you're solving for. And then hit alpha, enter, and we get the answer of $740.84. That's 836. That 6 rounds that up. Now, Alex is probably going to get slightly different answers. That's because they're using that big honkin' formula. That formula is actually not as accurate as what we're using. Our answers are actually more accurate than that formula. So you're going to be off some from Alex's answer. There is some tolerance built in to where if the actual answer was, say, $740 and say Alex got 93 cents and you have 84 cents, it should accept it, okay? There are instances where you put that answer in and Alex's answer was just far enough off that it's going to mark it wrong, okay? If that happens, I need you to let me know so I can go in and I can fix it for you. Right? So that's kind of the price you pay for getting this nice TVM solver that's going to do a lot of the work for you, is that Alex is using something different, so it might mark it wrong. So I'm willing to go behind you. You just got to let me know to go do that, okay? All right, so here's our monthly payment amount. And then part 4, find the total interest paid. Okay, we have not done one of these yet. The total interest paid down here is the total installment price minus the purchase price. All right, so it's the total installment price minus the purchase price. The total installment price also has a formula. It's right here. There's a lot of formulas in here, right? So you just have to be aware of it. So don't feel like that, oh, all the formulas are on the formula sheet. I don't really need to do any of the homework or any of the practice because I'll just use all the formulas. That's well and good, but you have to know when to use what formula and how to use them. So you still need to practice. Okay, so the total installment price is this formula right here. The payment amount times the number of payments plus the down payment minus the purchase price. So let's start plugging and chugging here. Payment amount comes from up there. The number of payments is capital N. The down payment, we did that in part 1 on the previous page. The purchase price was given to us on the previous page in the original problem. You can type this in all at one time in your calculator. You should pause it, type that in, and make sure you're going to get the same answer as me. And we should get $94,252. Now this should be a little bit of a shock to you, okay? This is not one of those where it's like, oh, this is a math problem where, the answer's not really realistic. No, friends. This is realistic. Okay? This is the real world. If you get a house for $160,000 and you finance it at 4.9% interest for 25 years, at the end of that 25 years, you will have paid $94,000 in interest. That's not a mistake. That's not some wild math problem of somebody, toting around 800 watermelons, crap like that. No. This is the real world that you've been waiting for. When you've asked your math teacher at some point, when will I use this? Here it is. And it's scary. I know, right? This is terrifying. This is why you want to have the most amount of a down payment that you can have so that you don't have as much of a loan amount. You can lessen this number by trying to get a lower interest rate and trying to pay it off in less time. Now, that does mean you have to pay more in payments. So you want to pay the absolute most that you can afford in payments to try to avoid having to pay all this in interest. This is wild. But you need to see this to see that this is what the real world is like. It's scary and it's expensive. It's really expensive to be poor, isn't it? It's just depressing to see that and just think about my own mortgage. All right. Anyway. Next one is like homework number 4. We have a home purchased for $313,000 with a 5% down payment. Find the monthly payment if the mortgage is 6.75% for 22 years. All right. We are going to use the TVM solver for all of these. Okay. So we're going to go ahead and just get right into it. The beautiful thing about this one is that there was no multiple parts. Some of these are going to have like part 1, part 2, part 3, part 4, and it's going to look exhausting, but it's really kind of walking you through the problem, which is kind of nice. It breaks it up into more manageable steps. Okay. N, capital N, is the number of payments. We are making monthly payments for 22 years. Capital N is the number of payments per year times the number of years. If you multiply that together, you get 264. I don't use 5. That's your down payment amount. Okay. There's your I right there. The mortgage rate is at 6.75. Remember, you don't have to change it to a decimal. Okay, you can leave it as a percent. That's what that little percent symbol means. Your present value or your loan amount is the price of the house minus the down payment. Now, walk with me on this journey, okay? I'm trying to save you some steps here. Because this is the purchase price minus the down payment, I'm going ahead and calculating the down payment amount in this computation. All right. So this 5% down payment is where I got that from. And remember, it's 5% of the purchase price. So I went ahead and changed 5% to a decimal, because if you're going to do anything with a percent, like multiply, divide, add, subtract, you have to change it to a decimal. The only time we don't have to change it is right here. That's because the calculator will do it for us. Okay, so let's go into, apps, TVM solver. So N is 12 times 22. So there's my 264 total payments. I is 6.75. Now you can arrow to the next line or you can hit enter. The loan amount is $313,000 minus the down payment. That is 0.05, 5% of, means multiply, $313,000. be really careful. There's a lot of zeros happening here. And I can see you accidentally forgetting one here, maybe forgetting the one with the 5. But your loan amount is $297,350. Make sure that you look at these and ask yourself, does this sound reasonable? Your loan amount better be less than the price of this house because you put a down payment down. If you accidentally do a computation and say this ends up being way too low, or if it ends up being bigger, then you know you messed up somewhere. Okay, so there's that. We're going to solve for the payment because it says find the monthly payment. And then, of course, we're paying it off, so that's 0. And then monthly. So payment, so alpha, enter. Wow, we get a payment of $2,165.02. That's steep. So that might feel really big, but you got to look at the price of that house. So that house is really pricey. So it kind of makes sense that this is going to be, kind of up there as well. And I want you to do enough of these examples that you kind of get a feel for what is reasonable for this. Because I don't want you to, look at this $313,000 house and accidentally solve this and get something like $21.65. Y'all, if your mortgage is $21.65, I don't know what kind of busted shack you were living in with 2 cardboard walls and half a cardboard roof. But it's, $21.65 mortgage is pretty low. That's some slumlord prices right there. So, yeah, you might want to rethink what went wrong there. So, or you just got a really, really good deal because it's like, haunted or something. So, either way. All right. Now, homework number 2 and number 5 have closing costs in them. The closing costs are these costs associated with the mortgage, okay? It's the cost to do that closing. That's when you actually buy everything. And there's like the stack of papers that you have to sign a bajillion copies of and just hope that there's not something in there that you're signing away your firstborn child or something. They have these closing costs. They're added on after you subtract the down payment, okay? So the amount of your mortgage, remember, mortgage is just a house loan name. The amount of your mortgage is going to be your selling price minus the down payment, but then you're going to add in those closing costs. Now, that's assuming that you're financing in those closing costs. Some people choose to pay those with the down payment. It's up to you as to how you do it. You can roll it into your mortgage or not. Alex goes ahead and assumes you're rolling it into the mortgage. Okay? So just keep that in mind when you're doing these 2 examples. That you have one extra little step in there. That when you're doing that calculation for the present value, it's that selling price minus the down payment plus the closing costs. All right. This one, example 3. This is like homework problems 6 and 7. Now, let me just go ahead and tell you that these problems, you are not going to like them. All right. This is not because they are difficult, but because they are tedious. Okay. The calculations involved for these are nothing more than some multiplication, maybe some subtraction. It's not much. Okay. But you're going to dislike it. So what we're doing is calculating the payments for what's called an amortization table. Now, an amortization table is going to be this really long table showing you how each payment that you make toward a loan, specifically a mortgage, how much of that payment is going to interest and how much of it is going to the principal. Okay. Now, the word itself, amortization, you'll see the word mort in here. That means that this is actually meaning to kill a loan. So the word mort is like, a prefix meaning death, like a mortician, right? So it means the death of a loan. Now, like I said, this is going to be tedious, all right? The computations are not hard. It is just very tedious as to where to look and what computations to do, okay? So here's what we got. We're going to find the first three payments for the table for example 2. Okay, so from the previous example we just did, we had this payment amount. We had this loan amount. Now that's not the purchase price. That was the purchase price minus the down payment. That's my loan amount. And then there's my interest rate. So that's the stuff that I need. I don't need anything else from example 2. The amortization table is going to have this to where you fill in the interest, the payment on the principal, and then the balance of the loan. This is showing you of this payment amount, how much of that is going to interest and how much of that is going to principal. When we say principal, we mean is actually going to pay off your house. So you want more of it to go to principal than interest. But in the beginning, you're going to see that that's not going to be the case. Okay, as the payments go on, more and more of it will be going to principal and less to interest, but it is definitely front-loaded toward interest. Okay, so I've color-coded these to try to help with the computations. So part A, this first item right here is the amount of interest. The interest per month is going to be your starting balance for your loan times the interest rate as a decimal, all divided by 12. Okay, starting balance is this loan amount. The interest rate, as a decimal, so we do have to divide that by 100, and then divided by 12. That's because it's 12 equal payments. So we're going to take that starting balance. This is the interest rate, 6.75, divided by 100. That changes it to a decimal. And divided by 12 because it's it's monthly payments. That's why. So multiply that out on your calculator, divide that answer by 12, and we get this. Okay, this means this much goes in this interest box. So this is how it's going to look in Alex. It's not looking good, right? That means of this payment of $2,100-ish in the payment, look at that, $1,600-ish is going to interest. Ugh, gross, right? Okay, the payment on the principal. That is going to be the payment amount minus the interest from part A. That means how much of the payment is going toward principal. Well, it's the rest of the payment. This part of the payment, this part of the $2,100 is going to interest. So the rest of it is going to the principal. So these two together make up your total payment of $2,165.02. So we just need to take payment minus the interest. So you can see how I tried to color code this here. Payment. So subtracting those, we get that only $492.43 of this is going toward your actual loan payoff. The rest of it went to interest. Then we have the balance of the loan. The balance of the loan is going to be your previous balance, which in this case is our starting, minus the payment on the principal. This is how much of your loan gets paid down. So we're going to subtract that $492.43, and we get this. This is your new balance of your loan. That means after one payment, your loan amount that was $297,350 is now down to $296,857.57. Now, the reason for this kind of amortization table is to show you at any point, like say after, say payment number, 40, you decide I'm going to pay off my house. Maybe you had like some super rich relative died and left you a buttload of money, and you're like, sweet, I'm about to pay off this house. That will tell you your payoff amount at that time. Okay? All right, so we can see that we have some basic computations, right? We got some multiplication, some division, some subtraction, right? No big deal. It's just very complicated in that you have to put the right numbers in the right spot. Now, we're just going to redo this, but here's the problem. These numbers are going to change every payment. Because with my next payment number 2, so here's all my information for payment 1. For payment number 2, this is my starting amount, not the original. Not the original right here. That was my starting amount for payment 1. But now payment 1 lowered my balance to this number. So now this is my new starting balance. Okay, so payment number 2, I need to find the interest, the payment on the principal, the balance of the loan. So remember how I called this part A, part B, and part C? I'm just going to kind of keep with that. So the interest. So I did all this in blue, you'll notice, to kind of show you all this was for payment 2, and all this was in red to show you it was for payment 1. I don't know if that's helpful or not, but, I try. All right, so the interest is still the balance times the rate is a decimal divided by 12. Those are the same each time. The rate and the 12 is the same throughout the same problem. It's the balance that's going to change, okay, because this balance is going to go down each time. So I'm going to take that number. All right, bust out your calculators. We're going to multiply that and divide it. And we get this is the amount going to interest. The payment on the principal subtracts that from the original payment amount. That's going to stay the same every time. That number is going to go right here. That's the amount that goes to the principal. And then this is how much this balance of the loan goes down. So I have to take this balance of the loan and reduce it by this much. So again, I'm trying to be very intentional with my colors so that you can see where I'm looking to get these numbers, because I know that it's very convoluted, okay? Now I know it asked for 3, but just to save on time, because this is a very long section, I'm going to leave payment number 3 to you. But payment 3 is going to be similar to this, only you're going to start with that number. So all this stuff that's in green is going to be this number now. Okay, not this one. It's going to be this new number right here. Okay, so moving on. Example 4, this is going to be like homework number 3. A beauty shop sells for $185,000 and a 7% down payment's made. 15-year mortgage is secured at 2.5% and the closing costs are $7,100. So there's multiple parts to this one. Part 1, find the down payment. Okay, so the down payment is this percent right here. So it's 7% of the purchase price. Okay, so it's 7% of that $185,000. Remember, this of means multiply, and we do have to change that to a decimal. So 7%, 7 divided by 100 is 0.07. And we're going to multiply that by $185,000. That gives me a down payment of $12,950. So there's my first number. Part 2 is to find the amount of the mortgage. That's the amount of the loan. So for that one, we're just going to have to take the selling price, subtract the down payment, and then add in those closing costs. Remember how I mentioned that earlier? That Alex is going to have you just work in those closing costs and just roll them into the mortgage. All right, so it's just a computation here. Selling price, given in the problem, down payment that we just found, and then the closing costs were given. So that means here is my mortgage or my loan amount. Part 3, find the monthly payment. We're going to use the TVM solver for this one. So let's look at that TVM solver categories and fill in everything. N is the total number of payments. How many payments per year times how many years? It's monthly payments. Now, it doesn't say in here, right, that it's monthly payments. Just assume that it is unless you're told otherwise. And it's for 15 years. And remember, you don't have to multiply these out separately. You can do that within that field. The interest rate's 2.5%. Make sure you use the right percent. The 7 was the down payment, so you want to make sure you use the right percent. That's the 2.5%. You don't have to change that to a decimal. The calculator will do it for you. The loan amount is this right here, that amount of the mortgage. And then we're going to calculate the payment. I told you these are pretty much standard for all these types of problems. So let's put all this stuff in. So we have 12 times 15 is 180 payments. That is at 2.5%, $179,150. And then put it in the payment field, hit alpha, and then enter. And we get a payment amount of $1,194.55. So I just put a little love note over here to you, just reminding you to solve that. It means you have to put the cursor on that field and you have to hit alpha and then enter. Last up, we want to find the total interest that was paid. Okay, the total interest paid is the payment amount times the number of payments minus the loan amount. Now, I did this slightly different than I did before. Before, I did the total installment price and stuff like that. Here, I'm just trying to make it a little bit easier, okay? We're just going to take the payment amount, that's PMT from this menu right here, times the capital N, the number of payments, minus your loan amount, which is your PV. So here, we're just going to pull these three numbers from this TVM solver, okay? So payment amount, we just got that. My N value was 180. And then that loan amount right there, that PV. And then this computation gives us the total interest paid was $35,869. Okay, so that wraps up the part on mortgages. So now we have the student loan part. I know this is really long, so bear with me. There are two types of student loans, okay? There are subsidized and unsubsidized. Now, subsidized loans do not accrue interest while you are in school or while the loan is deferred. Unsubsidized loans do accrue interest while you're in school and while the loan is deferred. Okay? If your loan is subsidized, you're just going to calculate the payment using the TVM solver just like you would with any other loan. Okay? So just know when you're taking out student loans, you might have one or the other or both. You might have a certain amount of subsidized and then a certain amount of unsubsidized. Okay? I had a little bit of both with my student loans. You prefer, trust me, to get the subsidized ones because they're not accruing interest while you're in school or while the loan's deferred. Now, what that means is when you take out a loan, you don't want to have to be paying, earning interest. Well, I say earning, accruing that interest and having that interest added onto your loan amount while you're in school. Okay. You would prefer that interest not start until you start your payback period. You prefer no interest at all, but that's not really an option. So deferred means that the loan is not being paid back for some reason. Like a lot of times when you first get out of school and you graduate, you can say, hey, I'm not going to pay this back for 6 months. They'll give you that grace period to go ahead and find a job, and it's called a deferment period. Okay, so really, we're going to focus on the unsubsidized because these are going to accrue interest while you're in school and while the loan is deferred. Now, what it's going to do is they will send you the loan company will send you notices in the mail and say, like every quarter or something like that, and say, hey, here's how much interest has accrued or accumulated during this period. Do you want to pay this interest now, or do you want to just roll it into the rest of your loan and pay it later? If you can pay that interest bill, pay it, because otherwise you're going to get this bill and it might not be for very much, right? Because it's just the interest on, say, like, for maybe a year or maybe a quarter or something like that. And you might just think, whatever, I'm not going to bother paying it, just roll it into my loan. But enough of those get rolled in, and then you start having to pay interest on interest. So that interest really does add up faster. So just something to think about. All right, so if your loan's unsubsidized, you have to calculate how much interest accumulated or accrued while you were in school and while the loan was deferred. Now, like I said, the deferment period changes for people. A lot of times it's just 6 months grace period when you get out of school to get a job, and then the payments start back up. You can request a deferment for any number of reasons. Like say you were in the hospital long term, you can contact the student loan company and say, hey, I can't make my payments right now. Can you defer them for 6 months, 3 months, whatever? So we add on this interest onto the loan. Then we're going to use the TVM solver. Now, to calculate the interest for these unsubsidized student loans, we have formulas, because of course we do, right? We're going to calculate this, and I'm going to have to do this like Alex does, okay? It's going to really walk you through it. The annual interest is the principal times the interest rate is a decimal, because this is an annual interest rate. So this is going to give me my annual interest. Then we're going to divide it by 365.25 to get the daily interest. That's the amount per day you're paying. Then we're going to multiply it by the number of days in a month to get the monthly interest. Now, if you're like me, I stopped right here and was like, what if I just take this step out and just take the annual interest and divide it by 12, right? 12 months, duh. Yeah, that's not how Alex is going to work this. And that's because the way that daily works is that it's not equally split by all the months, because it really is dependent on the number of days in a month. However, Alex goes and uses 30 days for all the months, even though in the real world, when your student loan company is figuring out your interest, it's not going to just use 30. It's going to use however many days are in that month. So, but anyway, this is what we're going to follow. All right, so here we go. This is going to be our last example. So you can see we're in the home stretch here. We're going to find the monthly payment on the loan. Assume the term, remember that's the time of the loan, is 10 years, and it starts after the deferment period. So this is how it's worded in Alex. We have a loan amount of $8,500, 6.7% interest. The student graduates 2 years and 6 months after the loan is acquired, and payments are deferred for 6 months after graduation. All right, first, let's calculate the amount of interest that accrues during this 3-year period. Now, I said 3 years because, notice how this is highlighted in yellow, because the interest was accruing the entire time you're in school, 2 years, 6 months, and then deferred for 6 months. So that's a total of 3 years. The annual interest is my principal amount, $8,500, times the interest rate is a decimal. Remember, you got to take that and divide it by 100. 6.7% divided by 100 is 0.067. There's my annual interest. Divide that by 365.25. Remember, that's division, top divided by bottom. So you should break out your calculator and be doing these computations with me to make sure that you know what I'm doing here. That gives me my daily interest amount of $1.56. Multiplying that by 30 days gives me a monthly interest of $46.80. That means the total interest that accumulated or accrued during that 3 years, 2 years, 6 months plus 6 months, is 36 months times the monthly interest. Now, here's something to note. When I first did this example, I just got the annual interest of $569.50. And I said, okay, so there's the annual interest, and it's just for 3 years. So I got my interest, instead of $1,684.80, I got $1,708.50. And I was like, why am I so far off? Because of the way Alex is calculating it based on this 30-month day, I ended up with more interest than I needed to. So, lesson learned. So now, as tempting as it would be to just multiply that annual interest times 3 years, we are going to have to use this for months, okay? 36 months. So annual interest, dividing it by the number of days in a year. So that is that right here, 569.5 divided by 365.25. Rounded it to 2 decimal places because it's money. And then times 30 gives me this monthly interest. And then it's for 36 months, 3 years. So here's the interest that accrued during you being in school and the deferment period. Rolling this into your student loan amount adds that onto your student loan amount of $8,500. Now we use the TVM solver. So we're going to pay this back. It says 10 years. There it is right there. So we have monthly payments for 10 years. Okay. And then the interest rate, 6.7%. This PV, this loan amount, is right here, that computation I just showed you. And then we're going to solve for the payment. So let's go into the TVM solver. Number of payments is monthly for 10 years. That's 120 payments, 6.7% interest. That's my loan amount of $8,500 plus that $1,684.80 of interest. So now my loan is up to $10,184.80. Blinky blinky on the payment field, alpha and enter. That gives me a payment amount of $116.69. So that's how much my payment's going to be. Now, to actually do this real world, right here gets messier because you have to figure out during those 3 years how many months have 30 days, how many have 31 days, and then you got February, and you have to figure all that kind of stuff out and get the monthly interest for those different months with different days in there. So that gets a lot hairier, okay? Once you calculate all that interest, then it gets added on. Now, Alex just tries to simplify the process for us by just saying, hey, let's just assume a 30-day month. But I just want you to know that that process, is not quite real world, but close enough. So, all right, I know this was a really long one, but this finishes up 7.6 for us.